taking notes, it'd be easier just to pay attention.
Yep. So here, I started recording. I'll just flip through the slides here real quick, so they're at least at the beginning of the recording, so you can see the slides.
Thank you.
All right. So we talked about what an API is. We talked about how information is transmitted between the two endpoints. Now we're talking about kind of our modern APIs, this idea of RESTful APIs, which are kind of, if we just throw in here one additional thing, these are the upgrade from SOAP-based APIs. So this was an early standard defining how APIs should be written.
Mm-hmm.
Right? And before we had SOAP, everybody and their brother just had their own little way of handling APIs. All right, so you already referenced this earlier where you said, well, with Ruby, you've used RESTful endpoints or RESTful routes, I think is how you called them, right? So
yeah.
the current standard for doing these things are through these things called routes, which we'll talk about here in a second. But, so we're looking at kind of an evolutionary step here for how APIs are written. Early on, everybody just picked their own poison. Then we had SOAP, which kind of gave a standard around what function calls should be available, and usually during the SOAP era, data was transmitted using XML.
Mm-hmm.
Then we kind of came out of that into the RESTful era of APIs, which is kind of interesting because we view those as our new cool kid, but it's actually based on something so old, from the early days of the internet. And what's nice about that is it's time tested. Why use something like SOAP where, fine, SOAP was time tested as well, but HTTP has certainly been through the ringer, right? This guy's been around the block a couple dozen times. So, the punchline is we already know that HTTP works. We've been using gets and posts for years with websites. So now we're just going to say, there's 4 functions here. Most people aren't using these other ones. And really, when you think about the purpose of APIs, getting back to this guy right here, the purpose is let's get data between 2 points. What kind of crap do we want to do with data? Well, we want to retrieve data. We want to create new data. We want to update existing data. And we'd like to delete some existing data too. Those are the things that we might want to do with data. And we just so happen to have 4 functions with HTTP. So get is retrieving data. Post is creating new data. Put is updating existing data. And then delete is deleting existing data. All right, so now understand that RESTful APIs, they talk about the sandwich that is the software layer. So if we kind of draw a picture of this, we have the website. So this is our web client. So web browser, whatever. Web client talks to, we're going to have a web server here, but that web server is now abstracted by something else. So now you have, in your world, we kind of have this stack here. So let's talk. Let's say this is a Ruby site. Okay, so it's a Ruby site, and here we'll change the color of this guy because Ruby sites are certainly going to be orange. Well, no, actually they should be red for Ruby. All right, perfect. And that Ruby site then exposes routes.
Yes.
Okay. And at the end of the day, what is a route? A route is just
an address.
Yeah, they're endpoints. They're / whatever. All right. So this a route is various things the API can do in terms of those 4 HTTP methods. All right, so let me just kick this down the line here, and then we'll shrink this guy down. So, so for example, we might have something like get user / user ID. That might be one of your routes. This guy would certainly be implemented as a get. We're retrieving information, right? As opposed to create user / let's say user ID and Yeah, but just for the sake of argument, let's go ahead and we'll pass the password in a completely insecure way. All right, so password's just part of the URL in that case, but in any case, we're creating something new, so that would be implemented as a post, so that route would be a post-based route. If we're updating the email address for a user, it would probably take the user ID and the new email, and that would be a put. If we're deleting a user, that would be a delete. So in any case, that's what those routes are. The routes are kind of like function names. What they describe what this endpoint does. Yep, an action. They describe what this thing is supposed to do, and then the methods that you call, whether it's a get or a post or a put or to delete, give you the indication, if you're following the standard, of what's the outcome of this function call or this action should be. How is this going to change the quote database? Now, nothing we say here indicates how this data is actually being stored.
Sure.
All right, so behind the scenes here, we have another dude that is going to be our database. All right, and this database could be all sorts of things. This could literally be a file. It could be MySQL, so we can say file, MySQL. It could be parse.com, something in the cloud, Google App Engine. Anything under the sun. Doesn't really matter. So the idea of RESTful doesn't indicate how you're storing your data. It gives you an interface into your data.
Yeah, it's just targeting a given cell.
Right, but understand that the old way of doing this was your web, your client. So in this case, this was a web client or an iPhone app or whatever used to talk directly to the database.
Yep.
Without going through this middleman to clean it up. Providing this middleman now makes it so that if, for instance, Instagram wants to expose some of their data to applications, they just need to create this single API, and now web developers can use it. iPhone developers can use it. Android developers can use it. Mac developers can use it, so on and so forth. They can all get that information through this same standard API. Now, some of those places also then provide what's called an SDK. So sometimes there'll be a client side, let's call this a client SDK. And what this client SDK is let's say that let's say you're writing your website in PHP, for example. There could be a PHP SDK that that knows how to talk to, let's say Instagram would create a PHP-based SDK that makes it convenient for PHP developers to abstractly talk to the Instagram API. So rather than you talking directly to the endpoints, you would say create user. You would call a local function from that SDK, and it would do the magic of talking to the API behind the scenes. So that's a convenience, and this is kind of the important thing that a lot of developers miss out on. So, if I'm if we keep using Instagram as our example here, let's say that let's say this is going to be a PHP website. All right, so that's one of the things I'm building here. All right, and let's just say that there happens to be a PHP SDK. All right, so everybody's happy. And then let's go ahead and let's say that there is we're going to have an Android app. And let's say there's also, it just so happens that they've provided a Java SDK for Java developers, which is the language the Android people use.
Sure.
Okay? And then finally, let's say that there's also going to be an iOS app. But oh no, there actually isn't a Swift SDK.
Got it.
Are the iOS people screwed? No. They can just talk directly to the RESTful API.
Yep.
So those SDKs provide conveniences. It's just one layer, but the iOS people can just write their own SDK, which just opens up a network connection, calls the correct endpoint, sends the correct information, receives the information in JSON, and parses it out. So they're not screwed. They just didn't get the extra little power tool, right? So that's something that a lot of people miss out on, where when they're going to design a technology, they all of a sudden say like, oh, well, I'm running an iOS app. there isn't an iOS SDK from Instagram, so I can't use Instagram. Okay, any place that has an API today, it's going to be a RESTful API. That's the important part. Okay, that they have an API, and that API you can talk to with any application. You don't have to use the Java SDK from Instagram for your Android app to talk to it. It's just a convenience. It's a tool that you might use. All right, so that's kind of the API discussion.
It's fantastic, and I understand more about it than I expected. It's, again, you just do a great job of explaining it. So that was super.
All right. So then you want to talk about responsive?
I want to skip to the libraries because responsive I could BS my way through. So while I have your time, I think JavaScript libraries is probably more important.
Okay. Yep. So, and you know what? I actually think we maybe even already talked about. Nope, we didn't. Okay, no big deal. All right. So the idea here with JavaScript libraries, there's all sorts of technologies you've heard of. So you've heard of just JS, you've heard of Ajax, you've heard of jQuery, you've heard of Angular, you've heard of React.
Which is the hot one right now.
Yeah, so...
Flavor of the month.
Yep, exactly. These four guys are all the same.
I know. Okay, good.
Right. So every
I
one
like
of
where this is going.
Yeah. So every one of these guys, so in the early days, JavaScript, so JavaScript is our, let's call it our original front-end dynamic programming language. And why did we need this? We need this because HTML is not a language. It's not a programming language. It's a data representation language.
Yeah, representation, that's what I was after.
Yeah, it's a data representation language, so we need a tool to complement HTML for dynamic logic, let's say. You know, so if you want to do form validation on a website, you know, the old way of doing that, the stupid way of doing that would be you would just send the contents of your form. If you didn't use JavaScript, let's say, you would send the contents of your web form over the internet, the web server would receive it, notice that you didn't fill in half the form, and then spit back a result saying you didn't give me enough crap to build your account. Okay, well now you just made a whole bunch of internet requests there and spent a whole bunch of time to get nothing out of it. JavaScript, and you put a burden on the server. So if you have 5,000 computers all wasting the server's time like that, you're hurting your optimization. So now if we use JavaScript, which runs on the client side, runs on that user's computer, the only thing it's affecting is that user's computer. It's not putting any burden on the server until at the very least he knows that when that information is sent to the server, at the very least you filled out the form completely. You could still get an error message, but it's at least now time to try. So that's the whole purpose of JavaScript on the client side. So this is our original front end, which we can also, this is also client side, which we can also say is, so front end, client side, that's fine. Let's just say that.
Yeah, I understand that.
Okay.
That's cool.
These are synonyms, front end and client side. These are things that get thrown around, okay? So that's our dynamic programming language. Now, what was the early problem, though? Let's assume you were using JavaScript. The early problem was when the user, well, here, let's write it up here under the problem. So we'll say problem, when the user clicked on the page, a full page refresh would be required to show something new. All right, even if all you were doing is trying to expand, a drop-down menu or something like that, you know, where you really wanted to look at the exact same page you're looking at right now with one little tiny change. So what is Ajax? This is a JS library that manipulates what's called the HTML document object exposed to JavaScript by the browser. So that pages can be rewritten.
Is it the object or the element?
Well, the object contains elements.
Okay.
So the document object contains all the different divs and stuff like that that's in your web page. So at the end of the day, what this gives you is it gives you programmatic access to the current page so that you can make changes dynamically to the current page, rewriting aspects of the current page.
Yeah, you can narrow it down and rewrite some very small detail.
Correct.
So you're not reloading everything and using all your bandwidth and processing power to fill in 100% of it. You only need 3% of it.
That's it. Okay, so the Ajax solved the problem of not having to reload the entire web page. You just had to reload a certain part of the web page.
Yep.
JavaScript is that on steroids. Angular is that on steroids. These are just evolutions of each other that have exposed new, more powerful ways. So really, what did jQuery do? So if we're going to say on steroids, jQuery is Ajax. Oh, yeah, I'm off a key here. Ajax with a simpler means to change the document. So a better language for changing the document. So it's less cryptic. Where in Ajax you could do it, but you were kind of like pulling teeth to get in there and manipulate stuff. jQuery gives you kind of a almost like, we go back to this API picture here.
jQuery is very CSS-ish.
Yep. So really, what jQuery did is it almost gave us an SDK for Ajax.
Okay.
All right. So it gave us a layer to talk to Ajax, maybe in a friendlier way. Same thing. Angular does that. It kind of, so let's say Angular learned from, and in some cases improved, jQuery for talking to Ajax, let's say. And we could just write the exact same thing for React. These kind of came out of different, I think React is, what is it, Twitter and Facebook?
Facebook, yeah.
Yeah, I think React is a internal library that Twitter and Facebook created for talking to Ajax to make their sites more powerful. So rather than using a third-party tool, they created their own tool. So, let's say this is Twitter and Facebook internal version of jQuery. And let's see, who made Angular? Is it Google? I think it's Google. I'm pretty sure it's Google, actually, but let's assume it is. Oh, here, let me just look that up real quick.
Where does the if I'm looking at a JavaScript stack, so I've got JavaScript, HTML, CSS running in my client, and I have, I guess it would be Node as my middleware, and then I've got a Mongo database on the back end. Am I describing the stack correctly?
If you're talking about, like, if somebody asks you, what is full stack?
The mean stack, right?
Yep.
Or any, I guess, I'm kind of moving away from what I'm interrupting and changing course a little bit, because if I look at what you're talking about here, where say I'm importing, my client is importing React, right? I'm telling it we're going to use React as our library.
Yep.
So you're relying upon React to bring features in, bring different looks in that are sitting there on Facebook servers somewhere. How does that fit into the MVC? I mean, and I'm asking a tough question because I'm not exactly sure. Like, I understand an MVC in Swift. I understand an MVC in Rails pretty well.
Well, so how does which part fit into MVC?
Where does the library fit into that, or does it not necessarily fit into that?
Well, I mean, so are you talking about, like, if we're going back here to, like, the API? Is that what you mean when you say library?
No, a JavaScript library.
Okay. So, okay, I got you. So if we're using jQuery, let's say.
Is it really part of my MVC, or no, it's really kind of it sits towards the view side.
Well,
of the
it's certainly part of the MVC. I mean, so the thing is, you want to keep in mind kind of what is MVC.
Yeah.
Do we talk about design patterns?
Nope. No, we have not.
Okay, I mean this is super important because this place might throw design patterns at you.
Okay.
So what's a design pattern?
Well, I'm going to interrupt again before we jump into that and go back. Let's go back to the JavaScript.
Yep.
Am I right to say that jQuery, Angular, React, whichever library it is, also they bring in unique functionalities, and that there are other libraries that are specific to, if you want a lot of, let's say, like swiping, right? Mm-hmm. Swiping on a mobile device. There are libraries that develop specifically for people that are concerned with swiping motions on a screen.
Right,
correct?
But they would be built on top of one of these. So I did confirm Angular is Google. So really what you're looking at is jQuery was the first, and then Google made their own internal one, and then Twitter, Facebook made their own internal version of that with kind of, these guys are kind of focused on single-page apps. But really it's Google's jQuery. React is Twitter, Facebook's jQuery. So if somebody was, writing a swipe-based library for people who are Angular developers, there would be a third-party library built in terms of Angular for making swiping stuff more friendly, rather than you having to write it yourself.
It's not totally different. It would ride sort of on top of one of those three.
Well, I mean, it's just a library. So Angular is a generic library that lets a developer kind of do whatever they want. And let's say that developers decide that, it's common to do swipes. So I'm gonna write my own code that is written in terms of Angular to help with swipes for me, and then I'll release that code to the world in case it helps them.
Okay.
But it's still written in terms of Angular, so it might be, Angular _ requires Angular or something like that. It's no different.
It's not, okay, because I was kind of under the impression that people were developing things separate, but now it's seeing that it's a subset of Angular or React makes sense.
Yeah, well, why reinvent the wheel?
Yeah.
If you're painting, cool. if you're getting new paint for your house, you don't rebuild the house. You just put paint on the existing house.
Yep.
So now it's a painted house. All right. So design patterns. People horrifically overcomplicate design patterns. All a design pattern is a proposed good solution to a, quote, common problem. Okay, that's what a design pattern is.
Okay.
Notice I put good and common in double quotes. That indicates that there are literally an infinite number of design patterns. All right, so first of all, like if somebody asks you what's your favorite design pattern, that's like a stupid question. You should just kick them in the nuts, assuming it's a dude. But the punchline here is that you can, and this is like perfect for educators who are trying to write papers, because they can just pick a problem that they say is common in their world and propose a solution they think might be good, and somebody else comes along and just says, "Oh, well, I have a better one." It's like, "Oh, you're right, but I still got the publication." The publish or perish thing. But in any case, so we have some popular design patterns, though. So, for instance, one of them is the MVC. What is MVC? It says it's a good idea to separate your code from your interface.
Yeah, into these pieces. Okay.
That's it. That's the extent of MVC. Put your code in one place, your logic in one place, and your interface in another place, and then come up with some way of making those two dudes talk. Okay. Every technology is going to have their take on how to accomplish MVC.
Okay. You've refreshed my memory, and I think I have a pretty good grasp of that.
Okay.
So back to what drove us to design patterns. What would an MVC design pattern look like? And let's use, because it's trendy, the mean stack. How's that?
Okay. So what do you mean? What would that design pattern look like?
Well, like I know in Rails, for example, when I think of model view controller, I think of the view really as what people are being shown. And, I mean, it's self-explanatory. The view, the controller assembles things, and it really assembles two things. It assembles data, and it assembles that together with some type of view or what it's actually supposed to look like. So the controller is pulling data out of the model and some sort of layout instructions out of the view and then putting it on the screen.
Yep.
With the JavaScript library, is it totally separate from that?
Well, you have to be more
because the JavaScript library is not on. It's coming from somewhere else. It's coming from Facebook, actually, for example.
Well, fine, but it's part of your interface. Usually, when we talk about Node.js, JavaScript becomes part of your backend.
Okay.
So you actually use JavaScript in your controller for Node.js. But for most websites, the JavaScript libraries we're talking about, the Angular and the React, those stuff, that's part of your interface. All right, so where's the MVC for that? Well, what you can do is you could write, in the template. You could write JavaScript directly inside that template if you wanted to. That's allowed. More often than not, how is MVC accomplished with front ends? So usually you would write JS in separate file.
Separate file.
And embed in template.
Yes. Makes sense.
So that's how MVC is typically handled. But keep in mind that JavaScript typically is a small percentage of an interface. It's mostly there for form validation and then adding some magic to the front end, if you will. It's not handling large portions of the site logic.
Got it.
Is the punchline. So this would be maybe we call this mini MVC. So this would kind of be like, okay, well, we might as well extend this guy a little bit farther and say, let's just literally keep our look here and the function behind that look here. Yet we're going to keep the logic behind this entire experience over here.
Okay.
That's called the pure MVC. But MVC is any situation where we separate the look from the logic. That's the end of the day.
Makes sense. I think I confuse myself a little because in building even a simple Rails app, it's pretty easy for me to understand what the MVC is, as long as if I'm connecting to a backend.
Right. But don't overthink MVC is the point. The point of this thing is MVC means something very simple.
Okay.
And there's no difference between how Android or iOS or Rails handles MVC. They're solving the same problem. They just have their own terms for the different pieces and, that kind of stuff. But at the end of the day, you put your interface in one place and your code behind in another place.
Okay. All right, good. I think we're good there. This will be the toughest part for me, is explaining this sort of the JavaScript library and why I would choose one over another. And
let me just throw these out here right now, just in case they ask about them. These are probably your top 3 design patterns.
Okay.
Observer and Singleton are the other 2. Observer just says it's a good idea to be productive rather than wait around for an event to occur and be notified when the event finally occurs. All right, so if you have work to do around the house, it's a good idea for you not to sit in the driveway in a lawn chair waiting for the mail to show up. Go and do work and somehow be notified when the mailman finally comes. Okay, that's the observer. What's the Singleton? Singleton says it's a good idea to keep stuff that needs to be shared by multiple parties in a single place. That's a Singleton. Okay, so if you are just handing your keys to your friend, and it's just you letting your friend borrow it. It makes sense to just go ahead and hand your keys to your friend. You're injecting that value into your friend. All right, so that's injection. As opposed to, let's say you and 5 of your friends are sharing a car. You might pick a drawer in your garage or something like that, or a drawer in your apartment complex. Let's say they all live in an apartment complex that they all have access to, and you keep the keys in there. And when somebody needs a car, they check the drawer. If the keys are there, they can use it. If they're not, somebody else has it. Rather than you holding on to the keys and they have to go and hunt you down. So keep stuff in a single place where everybody has access to it. That's a singleton.
Okay.
So those are your big 3. If I were gonna, put a pecking order on design patterns.
Yeah, I mean, I've never dealt with anything but MVC, or really ever heard of anything but MVC.
But observer is something that you deal with in real life. Singleton is something that we all deal with in real life.
Yeah,
we're just giving them funky names for the computer world to make us think they're difficult.
Yeah. All right. Okay. Well, on responsive technique, I'm basically, if that comes up, I'm going to say, use a framework, like Bootstrap, and try to make the site look like it's not on Bootstrap. I mean, that's, if I have to do it from raw CSS, my gosh, tedious, a big challenge. Depending on the client, most clients, I think that responsive design can be achieved using something that's just proven itself over and over again, like an existing framework.
What does responsive mean to you? When somebody says
that the view is going to be presented in all kinds of different physical devices and various clients, and you need to adapt to physical devices from a large screen PC to whatever, iPad or an iPhone or an Android device or some massive Samsung.
Perfect. Yep, perfect. That's exactly what it is. So you can already speak You can speak intelligently about responsive. So your argument is,
with the first iPhone versions, first couple, I think up to number 3, which was kind of number 2, you didn't have to worry about it. You designed for the iPhone screen because the size was always consistent. Then they threw the iPad into the mix, and that's when this sort of began.
Yep. Oh, but it actually goes even beyond that, because now now when you're designing applications, especially HTML5 based stuff, if we're talking kind of web, you don't know how people are going to digest that information, and just resizing your information for a certain screen size sometimes isn't good enough. Sometimes you need to change the way something is actually being presented, to make it more applicable to looking at it on a tiny screen, that kind of stuff.
Yeah.
And
the order it's presented needs to be manipulated. I mean, I saw a real world example this morning of a WordPress site that, when you look at the home screen in a web browser on a computer, it looks fantastic. You go to any mobile device, and for some reason, WordPress is stacking irrelevant or the least relevant stuff at the top of the screen and moving into the good stuff 2 or 3 sort of, I don't know the word, maybe modules down the way,
So let's say something like this, and you can replace WordPress with all sorts of different technologies. But what's interesting about Bootstrap is that Bootstrap has a mobile-first mentality. It takes the site from mobile and expands it to desktop.
Even though it's usually built on a desktop, they've got, I forget, medium, small, and they have the pixel counts predefined as to when you hit certain pixel count, it's going to shrink it to this small model versus the medium versus the large.
Correct. Yep. Absolutely. You got it.
Yeah.
So responsive is easy. It's just an idea, and the idea is that it would be a great idea for us to consider what kind of clients our users are going to be using, and make sure our site looks reasonable, or make sure our site is presenting the look that we want it to present on all those different devices.
Yep. All right, we nailed it. I think that was great. I know what the order I need to sort of think these things through. I have no expectations or ideas as far as what's going to happen on Tuesday, but I'm excited.
Okay. So Shoot me an email after that. I don't even remember. Is this our third or our fourth session? Is this the third time we met or the fourth time we met?
We may be at 4 now. I'm not sure.
Okay. Because otherwise Thinkful's going to cut you off, I think.
That's 6, isn't it?
I thought it was 4, but I'll keep meeting as long as they don't bitch, so it doesn't matter to me.
Oh, for some reason I thought it was 6, but I could be wrong.
I don't know. Let's just meet next week, and then I'll turn it in, and if they bitch, then we'll know we're done.
Okay. All right, perfect timing because people just walked in the door.
Okay, I'll upload the video and send you the link.
Thank you. That'd be great, and I'll email you and let you know how this thing turns out.
Perfect. I'll see you same time, same station next week.
Yes. Have a good weekend.
Yep. You take care. Bye-bye.
Bye-bye.